In 3.2, we're going to introduce two shortcuts in order to prove that two triangles are congruent. The two shortcuts have some abbreviations, SSS and SAS. That's what we're going to talk about. That's the main idea. But before we get into those two shortcuts, the first thing that we need to talk about is the word postulate. These shortcuts are called postulates, and when I say that, some people always wonder, well, what does that mean? A postulate is just a mathematical statement of fact. So if we say something is called a postulate, it is considered a fact by all mathematicians anywhere. Like, for example, the sun rises in the east and it sets in the west. That's considered a fact. And nobody argues with it. You just go, oh yeah, that's exactly the way that it comes up and it goes down. You know what I mean? When we're here, where we live in the United States. Postulate is a statement of fact. The second word that we need to know is the word included. When a angle is included, if we're talking about angle A, it's included between side or segment BA or segment AB. And it's between that and side or segment AC or segment CA. This is the angle between these two sides. In other words, the word included, it means in between. It's in between these two sides. In other words, it's what's touching these two sides. And we can talk about an angle being included. We also can talk about a side being included. This side is included between angle B and angle C. It's the side that has an angle touching it and another angle touching it. Every side is included between two angles of a triangle. Every angle is included between two sides of a triangle. It's just a matter of figuring out which one is which. And that's going to be important because we're going to have different postulates in section 3.3. When we talk about angle side angle, and we talk about angle side, we have to use the word included to know which one is which. So that brings us to our first example. If you have your textbook and you want to turn to, I don't remember what page it is, but it's in section 3.2. What page is it for those of you, somebody who has their check sheet? What page? 130. 130? If you want to go to number 8 on page 130, I hope that's correct.
134 isn't on 134.
134, page 8. Feel free to turn there right now. I hope that's correct. I don't have the book in front of me, so. This is number 8, and it's going to ask you a question about that word included. In triangle HAT, between which sides is the given angle included? It's really important for us to label things correctly in geometry. They do not draw a picture for you. If you need a picture, you can draw the picture yourself. They're telling you there's a triangle out there that has 3 corners, and all 3 corners' names are H, then A, then T. If you want to draw the picture, you can. It's up to you. H, then A, then T. And they're talking about angle H is the given angle between which sides. This is included between which sides, basically. And I hope you can tell what it is. But don't just say angle ha, ha, ah, or whatever. Make sure you put the segment bar on top. Segment HA. You see what I did there? Try to make a joke. It wasn't very funny. Ha, ha, ha. Ah, okay. Maybe someday you'll understand my line of thinking. My line of thinking is very short-sighted. HT is the other one. Segment HT because there's a segment bar on top. And once again, I think I told this to you in 3.1. By putting a segment bar on top, you're telling me that this has a beginning and an end. It is a segment. It does not go on forever. These are my answers. Moving on. In section 1, we learned that in order for two polygons to be congruent, all their sides had to be congruent and all their angles had to be congruent to each other. The only exception to that was if it was the third angles theorem. What we are going to learn in section 2 and in 3 will be that we could have some other minimum pieces of information for triangles to prove that two triangles are congruent without having to show that all the corresponding parts are congruent. Meaning this: if I have a minimum amount of information, if I have that three sides are the same in one triangle and they are congruent to three sides in another triangle, meaning this is the same distance as this, they're congruent to each other. The doubles are congruent to each other. The triples are congruent to each other. If all three sides are the same, then all this triangle is congruent to that triangle. It means that all its angles are going to be congruent to each other, even if you don't know what the angles measurements are. If I was thinking about this from a construction standpoint, if I had, for whatever reason, I had a stick that was 10 inches long and another stick that was 12 inches long and another stick that was, let's say, 14 inches long. And I were to attach all those sticks together. And I had another set of them. And I were to attach all those together in the exact same spot at the endpoints to endpoint and endpoint to endpoint. And I were to make another one that was a 10, a 12, and a 14. By just knowing that the side and the other side and the other side, SSS, the sides, all three sides were the same, don't you think that all the angles would be the same as well? It's true. That's why this is called the side-side postulate. It's a accepted fact. Mathematicians accept it. You should too. If all sides are going to be the same, then guess what? All the angles are going to be the same as well. But you have to have a minimum of knowing all three sides are the same. I'm hoping that makes sense to you. If you were to have a side and an included angle and another side congruent to a side and the included angle and another side, you would know that the two triangles are congruent. Construction-wise, if I had something that was 10 inches and I knew I had to have a 45-degree angle, I had to have the 45-degree angle, and then I have something else that say it's 11 inches. How many triangles could you make that were 10 inches with the included angle of 45 degrees and 11 inches? Let me think about that. Those are your constraints. Side with the included angle has to be 45 degrees and another side. A side, included angle, another side. How many different triangles can I make? Can I make any other triangle now? Well, I think about that. Let me just sort of in my mind go to a different color just to play around with an idea. Let me draw this and connect it. I have a triangle right there. Is there any other way to make a triangle with a side, a 45, and an 11? Are these two triangles going to be congruent to each other?
Yes.
Yeah, it's a postulate. There's no other way to make it. As long as you have a side touching an angle, touching a side that is congruent to another one, the two triangles are going to be congruent. It's the minimum amount of information you need to prove that the two triangles are congruent. These are the abbreviations that you're going to use to prove that the two triangles are congruent with the minimum amount of information. They will never be usually given to you separately like this. Most of the time, the triangles will be drawn together. And in mathematics, do not assume anything is congruent unless it has congruent marks, unless it has a shared side, it has a shared angle, unless it has vertical angles, or it has congruencies because of midpoints. These are the only things that you can add to your drawing where you can add congruent marks or congruent arcs. Otherwise, do not assume that they are congruent to each other. One other thing that I had you write down was this sentence, and it says, read one triangle at a time. What does that mean? That means that you have two triangles here. Don't go and look at this and say, I have a side, and then jump over to this triangle and say, oh, a side, and then side. That's a side, side. No, one triangle at a time. This triangle or this triangle. You have a side and a side. Only pick one at a time. And it says in consecutive order, meaning I have a side touching a side. Don't go around the other way when there is not an angle or a side that are touching each other. You got to make sure that you are doing things in consecutive order, otherwise known as I have this side touching this side. I have this side touching this side. I have this side touching that side and side. One triangle at a time. Make sure that they're touching or in consecutive order. Don't add anything unless it's shared, it's vertical, or there's congruencies because of midpoints. Here are your last two examples. Number 9 and number 10 are in your book. If you want to do these in your book, you are welcome to do so. When you look at these two triangles, you have a side that is congruent to another side. I have this side that's congruent to this side, but one triangle at a time, you have a S and a S, and sometimes you're going to say, no, there's not enough information. If it was just the S and the other S, that's not enough. It's not SSS and it's not SAS. So what you have to do is you have to say, is there something else in this picture that they're not showing me, something that I am allowed to add to my picture? And I see a couple of hands, so that must mean that you see something. Do you see something? Say what it is, Kyler.
Vertical angles.
He sees a pair of vertical angles. Ethan, is that what you were going to say?
Yeah.
Awesome. So he sees a pair of vertical angles. So is this angle here the same as that angle there? Because they are vertical angles. You can only add things to your picture that you know for a fact are true. Vertical angles are always congruent. I'm even going to write that down. Vertical angles are always congruent to each other. I'm just writing that down just because later on, as I get to the proofs, that might help me out. Now, one triangle at a time. I have a side, an included angle, and another side. Is that congruent to a side, another included angle, and another side? A side touching an angle touching a side. Name the postulate you would use to prove the triangle is congruent. SAS. If you understood why it's SAS, please raise your hand so I can see how many understand this. Wonderful. That's the majority of my class. I think most of you get it. If you're looking at number 10, right now there's not enough information. You have a side and a side, and in the other triangle you have a side. You only have an S and an S. Are there any vertical angles? No. So then what you have to do is you have to look for anything else that is shared between the two triangles. If you were to split these two triangles into two, and you had a triangle up here and a triangle down there, is this line the same in both triangles? Are they congruent to each other? If there's ever a shared side, like this one is, you can add that the third side is the same in both triangles. And if you don't see it, it might be helpful for you to separate the two triangles so you can see that the third side is the same as the other third side because it's shared in both triangles. So this is the third side of this triangle and the third side of that triangle. You can only add it if it's shared, and that's shared. I'm going to say shared. There's a property for it, and I might as well write it down now. We're going to learn more about it later on. It's called the reflexive property of congruence. You touched upon it a little in Advanced Math 8 or in Math 1. But you may have forgotten it, so I'm just going to remind you, when something is the same as itself, it is the reflexive property. But that's not the question. What's the postulate you would use to prove the triangles are congruent? Why is this triangle congruent to that triangle? Which of the two shortcuts are we going to use? And if you said SSS and you understand, please raise your hand so I can see how many got it. Woo, that's a lot of you. Well done. We're going to stop your notes right there.